We're gonna continue our session today about the second quadratic equation. We talked from 2 weeks ago how we graph this function. But now we're gonna take how to graph this function again, but how to find the solution of the function or the equation from the graph. How we find the graph, how to find the solution from the graph. So we know this curve is representing the second quadratic equation. But how we're going to find the solution from the graph? Before we continue, to find the solution from the curve and the coordinates of x and y, the solution is where the intercept point of the curve and x-axis. Here is x, here is x. So, the intercept between the curve and x, here is the intercept point. So, the intercept point here representing the solution of the second quadratic equation. So, again, how we're going to find the solution of the curve of the second quadratic equation by the intercept point between the curve and x-axis. So, the solution is right here, right here. The solution is right here. So, remember first how we are graphing the equation. Using the table of the values to graph y equals 3x power 2 plus 6x minus 4. So, by using the table, remember the table, x and y, x and y. So, x here has too many values, like 1, like 0, like negative 1, like negative 2, and negative 3. So, what we're going to do by these values of x? We're going to substitute in x by 1 in the equation y equals 3x power 2 plus 6x minus 4. So, if we substitute in x by 1, it's going to be 3 by 1 power 2 plus 6 by 1 minus 4. So it's gonna equal 5. So it's gonna equal what? It's gonna equal 5. So the order pairs here will equal 1 and 5. The order pairs here will equal 1 and 5. We're gonna represent each value of x. So we're gonna do the same with 0 and negative 1, negative 2, negative 3. So 3 by 0 in the equation of the second quadratic equation, the example, 3 by 0 or 2 plus 6 by 0 minus 4. So 3 by 0 equals 0 plus 6 by 0 equals 0. So minus 4. 0 plus 0 minus 4 is going to equal negative 4. So the order pairs here 0 and negative 4. The order pairs here is 0 and negative 4. And here is negative 1 and negative 7. And here is negative 2 and negative 4. And at last, negative 3 and 5. So we're gonna represent all of these order pairs in the coordinates. So we're gonna find this curve representing the function we have. So where exactly the solution of this curve? The solution of this curve is here and here. I don't need the solution now, but between the curve and the x-axis, not here. So the solution here will be equal the solution here is the intercept between the curve and the x-axis. The solution is the intercept between the curve and x-axis. So here is the solution. I'm not asking now for the solution, I'm asking for the graphing, to remember the graphing, but for now. Okay? We have three cases for solution of the quadratic equation. The first one, if you have two unique real solutions. Why? Because the curve will intercept with x-axis into 2 points. So the curve will intercept with x-axis into 2 points. So the solution will be 2 points. If you have one only real solution, one unique real solution, when this will gonna happen? When the curve intercepts with x-axis in only 1 point, in only 1 point. So it's gonna be having only one solution. But what happens if the curve never intercept with x-axis? So the solution set will be no real solution, no real solution, no real solution. So for the next example, so here if the intercept between the curve and x-axis, here is x. The intercept here in -3 and -2. The intercept here is -3 and -2. So the solution that we have here is -3 and 2. So the solution of the set of the second quadratic equation we have here is -3 and -2. You can check the solution you have by factorizing, or the general rule. We took it for 3 or 4 weeks ago, the general rule or the factorizing. So the first one, using the related graph to find the equation to determine its solution. X power 2 plus 2x minus 3 equals 0. So after graphing by the first method, we took a table and find the x and y, and now we represented the order pairs in graph. So where is the solution of this second quadratic equation? So the solution is the intercept, we said it, the intercept between the curve and x-axis. So here is the solution. So the solution, -2 here, so the solution will be -3, -3, and 1. So the solution will equal -3 and 1. Next one, -x power 2 minus 6x minus 9. So where is the solution? The solution, we said it, to intercept between the curve and x-axis. So where is the intercept between the curve and the x-axis? Right here. So the solution will equal -3. But how? We have only one solution? Yes, because the curve intercepts only in 1 point between the curve itself and x. So the curve, the solution, will equal -3. Only -3. But here 3x plus 4 plus 3 equals 0. 3x power 2 plus 4x plus 3 equals 0. So the solution here will be, do we have any intercept between the curve and the x? So x is right here and the curve is right here. So is there any intercept between the curve and the x-axis? No, of course. So no real solution we have in this function. So we don't have any real solution for this function. Remember the curve, if it's maximum or minimum. We said it, if the x power 2, the coefficient of x power 2 positive, so that it will be maximum or minimum. Of course, it will be minimum. But if the coefficient of x power 2 is negative, so the solution, the curve will be maximum, right? Like this one. Here we have x power 2. The coefficient of x power 2 is positive, so it will be maximum or minimum. Of course, it will be minimum. So in the first one, if we need to find the solution, here is 1 and 5. 1 and 5. Why? Because the intercept between the curve and the x is 1 and 5. After you graphing this function again, to find the solution of the curve, we must find the intercept between the x and curve, the x-axis and the curve. So here, where is the solution? We don't have any intercept between the curve is down there and the x is up there. So is there any intercept between the curve and the x-axis? No, so we don't have any real solution. Here, after you graphing this function, we found the intercept between the curve and x is 1 right there, and 5. So the intercept here is representing the solution of curve. So the solution will be 1 and 5. 1 and 5. Here, it's a negative x power 2, negative 4x equals 0. Remember, the coefficient here of x power 2 is negative, so the curve will be maximum. But where is the solution? We said it. The solution represented by the intercept between the curve and x-axis. So the solution is negative 4 and 0. The intercept here is represented by 0 and negative 4, 0 and negative 4. And next one, negative x power 2 plus 36 equals 0. Of course, here will be maximum because the coefficient of x power 2 is negative. So, the solution here we have is negative 6, and 6. So, here the solution will be negative 6 and 6. Why? Because the intercept between the curve and the x-axis is negative 6 and 6. So, the solution will be negative 6 and 6. To find the solution for the next example, negative 3x power 2. So, before we see anything, it will be maximum because the coefficient of x power 2 is negative. So, negative 3x power 2 plus 3 equals 0. So, where is the solution? The intercept between the curve and x-axis. So, it's going to be equal negative 1 and 1. Negative 1 and 1. Here, do we have any intercept between the curve and the x-axis? Of course not. 3x power 2 plus x plus 3 equals 0. So we don't have any intercept between the curve and the x-axis. The curve is up there and the x-axis is down there. Do we have any intercept between the curve and x? No. So we don't have any real solution. We don't have any real solution. And next one, x power 2 minus 3x plus 2 equals 0. So the coefficient of x power 2 here is positive. So it's gonna be, yes, of course, minimum. So where is the solution? The solution is 1 and 2. The solution will be 1 and 2. Negative 2x power 2 minus 6x plus 5 equals 0. So the coefficient of x power 2 is negative. So it's going to be, of course, maximum. Of course, it's going to be maximum. But where is the solution of the curve? The intercept between x and the curve. The intercept between x-axis and the curve. So it's going to be equal negative 4 and 1. Negative 4 and 1. And here, the x power 2 plus 10x plus 24 equals 0. So, the coefficient of x power 2 is positive. The coefficient of x power 2 is positive. So, it's going to be, yes, minimum. But where is the solution? So, the solution here will be equal negative 6 and 4. Why? Because the intercept between the curve and the x-axis is, here is the x and here is the curve. The intercept between the curve and x-axis is negative 4 and negative 6. So the solution here will equal negative 6 and negative 4. Finally, 2x power 2 minus x minus 6 equals 0. So if you graph this function, gonna be minimum, of course, because the coefficient of x power 2 is positive. So where is the solution? The solution here will equal negative 1.5 and 2 because the intercept between the curve and the x-axis is negative 1.5 and okay, but I need to check something like this one. How you know How you know this solve is correct? How you know this solving is correct? You remember the factorization? We need two numbers. If you multiply them, it will give you 5. If you make it add between them, give you 6. So it's gonna be equal. So open to brackets first. Equal 0. So here is x, and here is x. I need to number. If you multiply them, it will give you 5. If you make it add, because the sign in the middle term, in the last term is positive, give you the number in the middle term, 6. So of course, 5 and 1. And the last term is positive, so I will give the sign of the middle term for both brackets. So here is negative, here is negative. So we have two brackets, x minus 1 equal 0 and x minus 5 equal 0. So we're gonna moving this number to the other side of equal by different sign. So x is gonna equal different sign. It's here negative 1. So you're moving the negative 1 to the other side of equal by different sign. So it's gonna equal positive 1 or 1. And here we're gonna moving the negative 5 to the other side of equal. So x will equal positive 5. So we have here x equal 5 and x here will equal 1. So do we have the same intercept of x and the curve? Yes. So if you're gonna need to check your solution in the graph by this method of factorization of the general rule, so you have to find the solution in graph is the same solution you're gonna find by factorization. So thank you and stay in a good health. I hope I can see you soon. Thank you.